Oh, welcome to the final video of this series. Took me a long time to record all of this, but I hope it's worth it. Now, what we're dealing with for the final video is this Stage 7 end of Unit 11 test. Now, you might wonder why there's no 11.4 video, but worry not, because 11.4 is more about applying the knowledge that you have acquired through exercises for the most part. And exercise 8 shows exactly that. So without further ado, let's start with exercise 1. So let's start with exercise 1. And it simply reads, a hat costs H dollars and a coat costs C dollars. We know that the coat costs $20 more than the hat. Write a function to show this. Now, the way I recommend doing this question is start with constants, start with values that you can try out on your draft paper perhaps. So we know that the coat costs $20 more than the hat. So let's say the hat is $5. If the hat is $5, then the coat will be $25, right? Now, if the hat is $10, the coat will be $30, right? If the hat is $15, so the coat will be $35. Good. Now, for all of these, the common thing that we've done is we kept adding 20, right? So we could write it this way then. 5 plus 20 equals 25. 15 plus 20 equals 35. 10 plus 20 equals 30. So the first number that we input was the cost of the hat. I'm going to highlight that in green. And the cost of the coat, I'm going to highlight in blue. And the constant thing that never changes was that plus $20, right? So now, instead of writing with constants, instead of writing with numbers, let's try to replace them with the letters that they gave us. So green stands for hat, and we know that hat stands for H, right? So H plus 20 equals C, which stands for coat. So the function is H plus 20 equals C. But if you've watched the first video of this series, you would know that I told you to write it this way instead. C equals H plus 20 because it looks more beautiful. But is it wrong to write it this way? Absolutely not. So simply enough, the answer is C equals H plus 20. So that's it for exercise 1. So let's jump right into exercise 2, and it reads, a man is M years old, and a woman is W years old. So that gives us the function W equals 4M. Describe in words the connection between the ages of the woman and the man. So let's write this function bigger, right? And let's try to understand what it means. So W stands for the woman's age, right? So the woman's age. I think it would be easier for me to write it with my keyboard, but I started anyways, so let's just keep at it this way. Now, and this stands for the man. In other words, for us to find the age of our woman right here, we need to multiply the age of the man by 4. So how can I describe this in words? Well, simply enough, all I'm going to write is the woman is 4 times older than the man. Done. So that's the answer to question 2. We move on to question 3 then. And oh no, we have a rectangle. What am I to do? Do not worry about it. Like I said, read the question first. You probably know the answer. It's not that hard. You can have shapes and algebra units. It's totally fine. So let's read it together. The length of a rectangle is L centimeters. So basically they did not give us the length, but they described it as the letter L. And they did not give us the width of the rectangle. They wrote it as the letter W. Now, just to double check, this is a rectangle, right? We call the shorter side the width, okay? So the shorter side is called the width, and the longer side is called the length. Got it? Excellent. Now, so we have a function here, w equals L minus 6. And what that means is, for us to find the width, every single time we will need to subtract 6 from our length. So the answer to A then, which says find the width of the rectangle when the length is 15 centimeters, is very simple. So W is equal to, replace the L with the value they gave you, so that's 15 minus 6 equals 9 centimeters. A is done. Now, find the length of the rectangle when the width is 30 centimeters. Same thing. So instead of writing, oh, it's not actually the same thing. My bad. So this time, and please be careful not to make the same mistake that I've done. I have not read my question well, because I assumed that I'm going to replace L by 30 immediately. But that's wrong, because this time they gave me the length of my width. All right? So that means I will have to replace W with 30. So in other words, 30 equals L minus 6. Aha. So how can I find L? Well, if you remember what we've done in Unit 2, yep, you heard it right, Unit 2, it would be an equation. So let me show you how to do it real quick, in case you forgot. So we know that 30 is equal to L minus 6. And for us to find L, we need to keep L by itself, right? So what we will do is we'll grab the number 6. But wait a second. We need to grab the number 6 with its sign and move it over where? We need to move it next to 30. So we'll grab the number 6 and we'll move it in front of 30. All right? So that means that 30 minus 6 equals L. And what is 30 minus 6? 30 minus 6 is 24. So that means L is equal to 24 centimeters. All right? So all I have to do is 30 minus 6 equals 24 centimeters. And that's question 3. We keep going, and we move on to question 4. And this is the start of 11.2. For the function y equals x plus 2, they gave you a bunch of questions. So let's look at A. Complete this table. Very simple. So every time they're going to give you a value for x, right? And every single time, you're just going to grab the number they gave you and replace x by it. Do you see? So when x is negative 4, y is negative 4 plus 2 is negative 2. Okay? Let me make this a bit smaller. There we go. Negative 2. So when x is negative 2, y is 0. Now, this is something extra, but did you know that I can predict the rest of the values without even replacing anything? And if you remember what I said in the previous video, y equals x plus 2 is in the form of y equals x plus c, right? C here is 2. And since y equals x plus 2 is in the form of y equals x plus c, then this function is a linear one. And since it is a linear one, when we don't skip x's, we will get the same difference between y's. So to go from negative 2 to 0, we added 2. To go from 0 to 2, we added 2. And to go from 2 to 4, we add 2. And to go from 4 to 6, we add 2. Now be very careful when you do this, because it does not always work, especially when the x's are not organized. See, for the x's here, they started jumping in increments of 2. So we know that the pattern will be the same downstairs. Got it? Good. Now, for B, they said use these axes, and when they say axes, they mean this graph, this empty graph. Use these axes to draw a graph of y equals x plus 2. Let's plot our points then. So when x is -4, y is -2. So let's put that there. When x is -4, y is -2. It's right over here. When x is -2, y is 0. Right here. Now, do I need to plot the other points? Absolutely not, unless you want to make sure. Therefore, draw a third point just to make sure. When x is 0, y is 2. When it's 2, it's 4. And when it's 4, it's 6. But then let me get back to what I was saying. Do I need to draw all of these points, or do I need to plot all of these points? Not necessarily, because technically y equals x plus 2 is a linear function, so you know you will eventually end up with a straight line. And a straight line, by definition, is possible to get with only 2 points. Okay? So that's the answer to B. Let's look at C now. So they said on the same axes, draw a graph of y equals x minus 1 this time. So we probably need to draw a table of values ourselves. But let's look at this again. Let's analyze it. This is also a linear function. How do I know it's a linear function? Why? It's because it's in the form of y equals x plus c. And since it's in the form of x plus c, I would probably only need 2 values to know what the line will look like. So let me pick easy values. Something that is subtracted from x, and it's going to be 1. So let's say when x is 2 and when x is 3. When x is 2, we just replace the x by 2, y is 1. And when x is 3, we just take off 1 from that, that's 2. We plot our points. When x is 2, y is 1. Let's look for that. When x is 2, y is 1. Done. And when x is 3, y is 2. And it's right over here. Now let's plot it. Or let's connect the dots, is what I meant. And there we go. Done. We have drawn the line of the function, or the graph of y equals x minus 1. Now, a piece of extra information is, when you draw equations of, or when you draw lines of functions that are in the form of y equals x plus c, you will soon notice that they will be all parallel. Okay? And that's it for question 4. We move on to question 5, and this time they gave us a new function. For the function y equals 0.5x, can you guess what form this function is? Well, if you said it's in the form of y equals mx, then you are definitely on the right path. And since it's in the form of y equals mx, therefore we know that it is a linear function. So they told us to fill in the table, to complete the table. Very easy stuff. We just replaced the x with the number they gave us. So -6 here multiplied by 0.5 is -3. And if you're wondering how I did it so fast, well, that's very simple to answer. It's because when I multiply something by 0.5, it is as if I divided it by 2. So -2 multiplied by 0.5 is the same as saying, what's the half of -2? -1. What is the half of 0? 0. What's the half of 2? 1. What's the half of 4? 2. What's the half of 6? 3. B tells us to draw a graph of y equals 0.5x. We already have our table of values. So when x is -6, y is -3, that goes here. When x is -4, -2, it's -2, it's -1. When it's 0, it is 0. And when x is 2, the y is 1 right here. And when x is 4, y is 2. And when x is 6, y is 3. And if you remember what I said in the video in 11.2, you will see that when it's in the form of y equals mx, it does indeed go through the origin, and that's your cue. That's how you find out that what you did was right, because y equals 0.5x, that's in the form of y equals mx, and since I know it's in the form of y equals mx, it will probably pass through the origin. When I connected my dots, did my line go through the origin? Yes, so I have probably done it right. And then let's look at C. On the same axes, draw a graph of y equals 3x. Again, y equals 3x is in the form of y equals mx. Therefore, it is a linear function. Therefore, we only need 2 points. And I will pick the easiest ones again. And for this, I will pick when x is equal to 0, because y would be 0 here, because 3 times 0 is 0. And x is equal to 1, which means y is equal to 3, because 3 times 1 is 3. Let's plot our points and let's use a different color. So when x is 0, that's 0. That's where the line passes through, the origin. Makes sense. And when x is 1, y is 3 right over here. And then we connect the dots together. And this will be the answer to question C. So let's make sure we align it. There we go. So in summary, the steps you need to take to draw a graph of whatever function they give you is you make sure that it's a linear function first. And since it's a linear function, I only need 2 points. And then I will see what y ends up being as when I replace x with the number that I have picked. You have the freedom to pick whatever number you see fitting, okay? And then you just connect the dots. And that's how you get the line. And this is the answer to question 5. Question 6 here is very easy. All they're saying is write the names of the lines A and B on the grids. Now A has the coordinates -3, 1.5, so right here. And B has the coordinates 1.5, -3, so it's right over here. But I don't know why they gave us the coordinates of those points. All I need are the names of the lines, and when they say names of lines, that usually means equations of lines, right? So what is the equation of line A? Or what is the name of line A? Since it is a line that crosses the x-axis at -3, we will just say x equals -3. B here, it is a line that crosses the y-axis at 1.5. So y equals 1.5. And would you look at that? We are done with question 6. Question 7 is, or says, a straight line passes through -4, -8, and 8, -8. Now, these are two coordinates of 2 points, right? And if you remember what I said, the first number here stands for x, and the second number stands for y. Same thing here, first number stands for x, second number stands for y. Now, I do not really need to draw a graph to write the name of the line, which is the question. All I need is to look at the coordinates of both points. And do they have something in common? Well, yes, because at y, they are both at -8. So we will assume that the line passes through the points -4, -8, 8, -8, has an equation of y equals -8. And we're done. Now the final question is question 8. And this is part of 11.4, and this is an application of everything that we have learned, plus something extra that I'm going to tell you about, okay? So, the graph shows the speed of a car as it slows down, and the bottom part, or the x-axis, shows us the time in seconds, and the y-axis shows us the speed in kilometers per hour. And we see that the car starts at a certain speed right here, and it slows down, keeps slowing down until it reaches 0, right? So the first question told us to find the speed of the car after 4 seconds. And for us to see what the speed of the car is after 4 seconds by reading our graph is simply enough. Draw a line that goes from 4, because 4 seconds, right? And keep going up with your ruler until you hit your graph, okay? As soon as you hit your graph, it will go at a 90-degree angle and it will fall on the y-axis. And wherever it lands, that will be the speed of your car at that exact time. So let's try to get an accurate measurement. All right, that seems good enough. And from what I can judge, it falls exactly on, I believe this is 34 kilometers per hour. So let us write 34 kilometers per hour. All right, that's question A. Now, how much does the speed of the car decrease every single second? Every second. Now, to answer this, we need to have a good knowledge of our graph. And there are a few things that we can say about this graph. Well, we know that at the start, our car was at a speed of 50 kilometers per hour. So 50 kilometers per hour, right over here. And after 4 seconds, because we've already answered it in A, remember? So after 4 seconds, right over here, it's at 34 kilometers per hour. So in the span of those 4 seconds, the car has decreased its speed by 50 minus 34, which gives me 16 kilometers per hour, right? So it decreased by 16 kilometers per hour in exactly 4 seconds. So for us to find what the speed decrease is every second, we just grab this value, 16, and we simply divide it by 4. So every second, the car decreases exactly 4 kilometers an hour. All right? So how do we write it? All I have to do is, in between parentheses, 50 minus 34, divided. I do not know how to write this division symbol on my keyboard, so this is for the division symbol. Divided by 4, which gives me 4 kilometers an hour. Now, if the car slows down at the same rate, how long will it take for the car to stop? Aha. So the car will keep slowing down at the same rate. As you can see, it's slowing down at the same rate. Okay, and when we say same rate, it's because it's a straight line. How long will it take it to completely stop? So if I'm losing 4 kilometers per second, and we started at 50, for us to know exactly how much it takes it, we just do 50 divided by, you guessed it, 4. 50 divided by 4 is, now for the sake of not wasting time, we'll just do this, 12.5 seconds. So exactly after 12.5 seconds, the car will completely stop. There you go. Now, one thing that I need to talk to you about is the concept of gradients, okay? So simply enough, all right? If the line that you see from left to right is decreasing, if the line is sloping downwards, we call it a negative gradient, all right? So if a line, for example, let's draw another line on this graph. If a line is going upwards, if it's sloping upwards, we call it a positive gradient. And if a line is completely horizontal, just like this red line, we will call it a zero gradient. All right?